Hello. This lesson is devoted to the 4Cs principle, our BioWell mantra about calibration and preparing the device to the work. How to do it properly, all the peculiarities in this process, I will try to explain in this lesson. Let's go. So what stands behind those 4Cs? Actually, it's very simple. Number one, C is clean the optics, the glass electrode of the BioWell device. It is a photography device, right? So we are actually using Kirlian photography device. So it's optics, the video camera is there. So we do those photos. It means that the glass, the optics should be clean in order to get high quality images. Well, it's obvious, I think. We are all using smartphones with the quite sophisticated and high-resolution video cameras there and photographic cameras there. So we know that if it's dirty, the images are not so good and they become blurry. Same story here. So in order to keep the device clean, you need to clean it not only before the calibration, but actually before every scan of every person. Because anyway, when you're scanning people, the sweat and some residuals from the skin can be left on the surface of the glass. And of course, they will somehow interfere with the emission. So that's why the best way to clean the optics is to use alcohol. You should have a spray with alcohol. Well, it's better to use the pure, magnificent smell. Or you can use the alcohol spirit swipes for injections that you can buy in any pharmacy store. So if it's not possible in your place, in your country, to buy pure alcohol. So you can do it like that. And we wipe it clean. In many cases, this process is not so easy as it seems. The thing is that when you're using this material, the tissue, actually you're polishing the glass and the static charge is being accumulated on the surface of the glass, because when the glass becomes dry, wiping with the tissue increases the static charge, and because of that, the next few scans after cleaning will be different and abnormal. Just because of that static charge. It's just physics. So there are some plays and scenarios of how to bypass that problem. Number one, you need to know the relative humidity of the air where you work with the BioWell. So we have a standard BioWell thermohygrometer. You can use any thermometer and hygrometer that you have. It's up to you. So I have this one. I click so I can find out what's the temperature and what is the relative humidity. So the relative humidity is now 55%. Actually, this is the perfect, ideal humidity for working with the BioWell. Then we can check what's the temperature. It's 24 Celsius centigrade and it's 76 Fahrenheit. Actually, the normal conditions for the BioWell functioning are written in the passport of the BioWell device. And it is written that the ideal environmental conditions are from 30 to 70% of relative humidity. So when it's around 50, 55, it's optimal. But what happens when the humidity is too high or too low? Both options are bad. When your humidity is going closer to 30 or going closer to 70, you will face different problems. What happens when the humidity is too low? So first scenario, when the air is too dry, it's close to 30% or even below 30%. Sometimes you can have such humidity in the mountains, or if you live in a northern city or your air conditioner is dehumidifying too much the air in the room, then the humidity can go very low. People who live in northern areas and their heating system is working in the house during the winter season, again, the air becomes Daily dry air leads to excessive ionization of the air, and also the sparks become more active. And that's why when you do the calibration and then you try to get proper scans, you may get inadequate results. Why it happens like that? Because when you put these calibrator insert into your device, and because of the dryness of the air, the discharge gets increased because of the dryness of the air, and the device, when it's trying to calibrate and gets the normal value of area and intensity, it will decrease the inner voltage of the impulse of the biwell device. That will lead to lowering down the voltage, and then when you put the finger, your ratings will be lower than usual. And it's not because the biwell doesn't work properly. It works as it should be. Value of area and intensity. It will decrease the inner voltage of the excessive ionization of the air, and also the sparks become more active. And that's why when you do the calibration and then you try to get proper scans, you may get inadequate results. Why it happens like that? Because when you put these calibrator insert into your device, and because of the dryness of the air, the discharge gets increased because of the dryness of the air, and the device, when it's trying to calibrate and gets the normal value of area and intensity, it will decrease the inner voltage. of the impulse of the Biwell device that will lead to lowering down the voltage, and then when you put the finger, your readings will be lower than usual. And it's not because the Biwell doesn't work properly. It works as it should be. It's simply because of too dry air, in which Biwell and Kirlian photography, the air discharge technologies, do not work well. So in such cases, wiping dry the glass, you just wipe it with this tissue, and you don't need to wipe it ideally. Some part of the wetness can be left there. It's not a big deal because of the dryness of the air, it will be evaporated very fast. But don't use paper napkins in this case. For example, I have a set of paper napkins always in my table here, ready for use. When the humidity is higher than it's needed, mandatory, obligatory. So when the air is too dry, either you have to somehow humidify the air and use the air humidifier in the office, in the room where you work with the Biwell, to get it closer to 40-50%, or be ready to get inadequate results in the Biwell. So the readings for human beings will be lower than usual. You will have lowered values of energy just because of the dryness of the air. What happens in opposite when the humidity is higher? For example, if you're trying to use in humid environments, countries or regions, go to Indonesia, Florida, or Brazilian forests, humidity is very high. And what happens to the air discharge then? Because of high humidity, the water molecules get condensed on the surface of the glass. And the problem with these small water drops that covers the surface of the glass is that they absorb those electrons that are being emitted from your finger, from the metal cylinder, and because of that, the emission will become lower. What will happen with the calibration procedure? The device and the software will try to increase the voltage in order to get those normal values. And as long as these water drops will absorb some part of these electrons that are being emitted by the object applied on the surface, like finger or cylinder, you will get higher values for the Biwell readings of the person than it's normal and adequate. So when the high humidity is there, you will get heightened values for people if the calibration is not done properly. How can you bypass that and evade such complications? After cleaning with alcohol, of course, alcohol should be used always to get rid of any fat, any residuals there, and water also. It dissolves it and evaporates. In Biwell 3, there is a ventilation canal there, through which the ventilation of air is constantly happening. So to some extent, it protects the surface of the Biwell glass electrode from this condensation of water on it. But in order to really dry the surface of the glass, after cleaning with this tissue, I do highly recommend to clean it afterwards with paper napkin. It will absorb all the water and dampness that is left there, not only on the glass but also around it, so the surface will be dry. Also, please pay attention that some cases you have to dry also the metal knob of the calibration cylinder. And only then you install it on the surface. Your device is ready for calibration. Please remember these recommendations whenever you use Biwell. If you travel with it or if you are working in the office, it doesn't matter. The calibration is a very important part of work with the Biwell. Because without calibration, the norms, the zero, are not being set, so the values of energy that you will get for different organs and systems, energy centers, etc., they will be anywhere. Heightened, lowered, inadequate. So it's very important to properly prepare the device. So you clean the electrode and you wipe it depending on the humidity. So if you have low humidity, you do not wipe with the paper because you will add a lot of static charge there. When you have high humidity, then you, after cleaning with alcohol, you use the paper napkin. Also, when you're scanning fingers, the humidity plays a role. If people have wet fingers, it's better to have these paper napkins nearby to wipe the glass and wipe the finger also. We will talk about the peculiarities of scanning fingers in the next lesson. So, number 1C, clean the optics. Number 2C, calibrate the device. Calibration of the device is a very important process. And I need to actually explain to you what is actually happening there in the software. Calibration of the device is a very important process. And I need and wipe the finger also. We will talk about the peculiarities of scanning fingers in the next lesson. So, number 1C, clean the optics. Number 2C, calibrate the device. Calibration of the device is a very important process. And I need to actually explain to you what is actually happening there in the software and in the device during the calibration process. Let's go to our software and see what's going on there. Here we are in the BioWell software and we go to the calibration screen. What do we have here? On the calibration screen we have the secret button in the top right corner called information. So when I will connect the BioWell device to the computer, I will see the information about this device when I click on this button. So let's take a look. See, now it's being recognized by the computer. Now it becomes active. It shows me the device calibration process. And I need to actually explain to you what is actually happening there in the software and in the device during the calibration process. Let's go to our software and see what's going on there. Here we are in the BioWell software and we go to the calibration screen. What do we have here? On the calibration screen, we have the secret button in the top right corner called information. So when I will connect the BioWell device to the computer, I will see the information about this device when I click on this button. So let's take a look. See, now it's being recognized by the computer. Now it becomes active. It shows me the chip ID, the serial number, when it was the first time when this device has been used, when was the last capture made, when was the last calibration made, how many scans were done, and how many captures were done on this particular device with this chip ID. So whenever you need some kind of tech support, you have to know where to look this information about your device. So please remember clicking the I button on the calibration screen. So there are two types of inserts that look almost the same in the BioWell set, in the BioWell bag. One of them is the calibration insert and another one is the accessories insert. What is the difference between them? If you look attentively into them, you will see that in this one, there is a wire coming from the metal spring and knob to here, to this contact. This contact is actually getting in contact with the ground plate here on the device. So this is a grounding contact of the calibration insert. And if you pay attention, that second insert, it doesn't have any wire, any contact. So this insert is used for the work with Sputnik, water sensor, glove, or any other electrode that you want to connect and use in environment mode or one finger mode. It's up to you. In the recent batches, you will notice that there is a symbol of Sputnik here engraved on the surface of the accessories insert. In the older batches, it wasn't there. And the contact for the wire. In fact, these accessories insert can also be used for calibration, but with some peculiarities that I will show later. So the standard way of calibration is using this calibrator insert with this metal contact here. We insert it into the bi-well device, and it can be done very easily. So you take it like that. The metal contact should be at the bottom. You put it there, and you rotate clockwise. Like insert, take out. Very easy. No need to press. It's very easy to insert. Actually, upside down, you won't be able to insert it because of this plastic part. So you insert it, it's ready for calibration. So when we click and the device is recognized by this computer, the operating system, you just click start, that's it, and you wait till the calibration is finished. Actually, calibration is divided into two phases. If you mention at the green bar at the bottom of the screen, you will see that in the first phase, it makes 2 scans. During these 2 scans, our software is trying to check the spectrum of this image, if it's correct. And the spectrum of the image is directly connected with the settings of the video camera. The sharpness, the intensity, etc., the different brightness, different parameters that we are checking, black level also there. And it makes 2 scans and adjusts the settings of the video camera if they are not set properly to get proper image. Second, because if you click on any image and you go to the spectrum, you will see that there is a spectrum of the image. So it should fit some standards. For example, you see here that it starts from specific intensity and finishes at specific intensity. So it should fit into specific norms. In the second phase of calibration, it does 4 scans in a row and calculates the average of them in order to set up the voltage correctly. Why? Because the cylinder should show 12,300 pixels of the emission of the glow. There is a range in which it oscillates plus minus 150 pixels, but the ideal is 12,300 pixels. If the image doesn't fit into that range, then your device and software will change the voltage either by increasing it or decreasing it, and then run one more set of 4 captures. So within 2 or 3 cycles, usually this device is being tuned and finds the best ideal voltage level for the bi-well device. If you're working in the same premises, your office is having the air conditioner and it doesn't change so much, then actually the calibration passes within those 6 images, 2 in the first phase and 4 in the second phase, and that's it, job done. So it takes less than 10 seconds to do the calibration. So the device and software are tuning 2 things. In the first phase, we are tuning the settings of the video camera to get the proper positioning of the spectrum and henceforth the intensity of the image. Then, second phase, we change the voltage in order to get the size of the emission at the normal range. So it should show 12,300 pixels. When it's being reached, you will get the message, calibration complete. Once again, the spectrum that we see here, it can be colored or it can be grayscale. So because initially the image is grayscale, like this. The coloring is artificial, just made by our software, just based on this palette. You see that on top of the grayscale palette, from 0 to 255 units, we have these colors. So from this range, from, for example, if I show you, see here, histogram position, I point here, it's 24 intensity, and there are 117 pixels of this intensity. And you see here it's yellow. We go here and up to 33 intensity, the color is yellow, and starting from 33 it's pale orange, then peach, then pink, light purple, dark purple, blue, dark blue, etc. So the coloring is made like this. We are intentionally coloring. You see here, this is special contrast palette where the high intensity pixels are being colored with red to highlight those places where the highest intensity pixels are. That's what being tuned during the first phase of the calibration is the angle of these, the position of this histogram, because it can be easily moved left and right, flattened, squeezed, or enlarged, depending on the inner settings of the video camera. So it's being tuned, everything is being set, it's all fine. So we have calibrated the video camera and we have calibrated the voltage. Now the device should be ready to scanning the fingers or any experiments you would like to make. Many people ask, how can I be sure that the calibration was correct? Well, actually with the BioWare 3.0, it's almost zero sense to double check the calibration because, well, it's quite sophisticated procedure. We are checking many parameters and tuning them during the calibration procedure. But if you still want to check it, you are welcome. So you leave the calibration cylinder on the surface of the BioWare device and you click stress scan. You see that in my database there is a special card created for cylinder checking the calibration. You can call this card and you can create it for yourself and you call it calibration, cylinder, whatever you like. If you add stars in front of the name, they will stay at the top of your database list, so it will be easier to find them, no need to search for them. You go to the stress scan, you turn on the fan and you click scan. 1, 2. Then you click analyze and you go to the parameters. The only thing that you need to check is the energy. If the calibration was done properly, the energy should be approximately in the region between 57 and 62 here on this graph. If the calibration, due to some problems, maybe humidity problems, temperature problems, or some objects left on the surface of the glass, you didn't clean it properly, it may jump somewhere else, and then maybe the reading will be out of this norm. In this case, you go back to calibration and you repeat it again. Then you can check it again, see if it fits. You see, in my case, it fits perfectly. Another way of calibration. So let's imagine you have broken this metal contact of the metal calibration cylinder, and now there is no grounding when you connect it to the BioWare device. What can you do? Or you have lost it, who knows? You can still use these accessories insert and connect it to the BioWare device the way it was done in BioWare 1 and BioWare 2. How it is being done? Same, you insert it, rotate, it's fixed. But in order to get the grounding, because without grounding there will be no calibration, you have to connect the accessories insert to the ground of the device. This small hole at the back of the device. So you take the bag and you take out the wire that you have there. Two options. Well, depends on the batch that you have. You either have a red colored or black colored wire. Doesn't matter. They're both with these small, tiny 1.5 millimeters banana jacks. So what should you do? You connect one side with the accessories insert here in front, and the another side you connect to the back of the device. Now, if you connect the device to the computer, you can do the calibration. So I connect it, we go to calibration, and we click start. Calibration complete. We can go again to this stress scan, to the calibration card, and click the stress scan and check if the calibration was done correctly. Click once, twice, and click analyze. 57.56. Previous calibration was 57.60. So actually calibration is done in the same way with wire, external wire, or if you haven't lost the calibration insert, it can be done with it. Then for the grounding purposes, we have an internal wire. So both options are possible. You can use this second one, it's up to you. What can happen with this calibration insert too? Sometimes it happens, the contact of this calibration insert can become damaged, scratched, and it will start emitting electric sparks during the calibration. And it, of course, will increase the noise, and two bad outcomes from that. Number one, these sparks can lead to disconnecting of your BioWell device from the USB port, especially on Mac computers, because they're more fragile and sensitive. Secondly, because of this spark, the emission will be much higher, and the software will think that you need to decrease the voltage. That voltage is too high. That's why you get those 16,000 pixels, for example, because of that spark. And it will start lowering the voltage. So, of course, sooner or later it will reach those 12,300 pixels. But because of that spark, the voltage will be very low. And when you will start with scanning fingers, you will get very low readings. So, whenever you are suspicious that maybe the calibration insert is not working properly, take the accessories insert, the wire, and do this wired version of calibration. Then there is a guarantee that there are no sparks there. So this is the way the calibration is made. This is the way how you can check the calibration. The norms for these checking of the calibration are 57 to 62 for BioWell 3. They're 55 to 60 for BioWell 2. There are no such exact norms for BioWell 1. They are approximately the same as for BioWell 2, but unfortunately in BioWell 1 series there were too many batches and they have different parameters floating. So this is the essence. So we have talked about only 2 C's from 4. The third C in our BioWell mantra is the correct positioning of fingers. And we will talk about the fingers, rules of capturing fingers in the next lecture. And the fourth C is cleaning the image. You have to be sure that the images that you scan, no matter for the calibration purposes or the fingers, they are clean. There are no external noises. There is no dirt there that can lead to blockage of emission, or an opposite, excessive too much emission. Please control these things. So let's repeat those 4 C's. Number 1, clean the optics. I have explained you the rules. 2, calibrate the device properly. 3, correctly position the fingers. 4, clean the image. So following these 4 C's rule, the quality of the scans that you will make and the quality of the results that you will get with the BioWell will be the best. You know that in some cases something goes wrong with the BioWell, calibration doesn't work, or something like you get inadequate results, and the recommendations that I have given here in this lesson do not help. In such cases, you can ask for tech support. And in order to help us to diagnose what's the problem with your BioWell device, we have a special feature in our BioWell software. Actually, we have 2 features. Number 1, you can simply send us the debug information. You click Save Debug Information, it will create an archive that you can further on send to the tech support, either to the local distributor or to support@biowell.com, or directly to me or lof@biowell.com. But your first point of contact is the local distributor. Second option, there is a special feature in our BioWell software that allows us, the tech support team and the distributors who are providing tech support, to tune and check your device remotely. You just need to log in into your account, connect the BioWell device, I will do it now, done, and we click tune device. So I am acting as a user. When I click tune device, you see, device is getting connected. It connects to the host, and the remote connection is established with our server, BioWell server, that is on Amazon in USA. And then you can leave your device connected like that, ready for calibration. Then a tech support person from the distributor or from our BioWell team can go into special app in BioWell and remotely get images from your device, check the settings, reset the settings, and try to solve the issue. So this tune device option is the remote tech support option encrypted into the BioWell software. Yep, so you can see here the tune device. View debug information is the option only for tech support people. For example, if you're giving a permission for a tech support person to remotely control your computer and do the actions on your device and on your computer, so this person will know the special password to enter this debug information and go to this secret part of the software. One more thing, with the calibration, you have mentioned probably that there is a button called reset. The reset button is for the purposes when you have problems and you don't get any image, even if you have correctly connected the calibration insert or accessories insert with a wire, but still the calibration doesn't work. Maybe the settings of the device were not correctly set or perturbed due to some conditions, I don't know. So you can reset the device to the factory settings. You just connect the device, click reset, and the device will be reset to the initial factory settings. After that, you can click start, and the calibration procedure will be run from scratch. You see now even the first phase of calibration has taken not only 2 images, but 4 images. So the process of tuning the video camera has taken more time because we have reset it to the factory settings. But in fact, the voltage stayed normal, see, within the normal range of the BioWell devices. So still calibration was done within those 10-15 seconds. That's it. So I have told you all the peculiarities of calibration, and the 4C principle. Rules of capturing fingers will be discussed in the next lesson. Thank you very much for listening, and if you have any questions, you're